Hello everyone, this is Xiongfei from the University of Science and Technology of China. I'm here to give a brief introduction of our work on applying clone analysis to deep learning software. So let's get started. As we all know, deep learning has been applied to many cutting-edge applications like self-driving cars, natural language processing, etc. However, with the number of deep learning models keeps increasing, it would be hard to effectively maintain deep learning models, and there is also a problem in testing the deep learning models. So it came to us that whether we could perform clone analysis on deep learning software, and to what extent the clone analysis technicals of traditional software could be adapted to deep learning software. Since the clone analysis of traditional software has been extensively studied, and it can help people to do maintenance or evolution tasks, if we could do clone analysis of deep learning software, it would not only help us to do the maintenance work but also improving the current testing methods. To finally figure out how does the clone analysis perform on deep learning software, we divided the clone analysis into three aspects, namely the textual clone analysis, which mainly deals with the source code of deep learning software, and the structural clone analysis, which cares about the structure difference between deep learning models, and finally the input-output based clone analysis, which deals with the dynamic behavior of deep learning models. Here are the datasets and models we used in our work. The table on the upper right corner is the accuracy of these models. The items below are the evaluation matrices we used in the experiment. On each level, we adopt two matrices to reduce the threat of validity. However, the clone analysis of deep learning software is slightly different from that of traditional software. For traditional software, we could obtain the structure similarity by calculating the difference between the abstract syntax trees or program dependency graph. But the deep learning models usually have their unique structure and cannot be compared directly. Besides, the output of deep learning models is usually a probability distribution, which is also different from the traditional software. So to deal with these two problems, for structural similarity, we obtain knowledge distillation to make all models have same structure and then calculate their difference using cosine similarity. As for the input-output semantic similarity, we use the Jason-Shannon divergence to calculate the difference between the output distributions. So here is the result of the source code level. Models, as you can see, models from the same family exhibit very high code similarity, and models from different families seem to be quite different. And except the VGG16 and others. The reason is that the VGG16 is written by the same author of the ResNet family and the DenseNet family. Their code style is quite similar. To sum up, results show that the code analysis on training programs could be effective in distinguishing the structure of different models when they are developed using the same framework. Besides Pycode similar, we also apply MOS for the above models. The results are consistent with this in the left figure. When it comes to the structural level, the result is getting interesting. First, their weights are neither too similar nor different, except the similarity with the model itself. Any other two models have a cosine similarity between 0.0 0.5 and 0.6, and the models from the same family fail to exhibit higher similarity. And here is the result for the input-output semantic level. And as you can see, we found that these models, except the net file, are functionally similar when the testing dataset is close to the training dataset. Because as you can see, if we change the input from Cifra10 to MNIST, the input-output semantic similarity fails to classify these models up. So it would be a question that on what representations or levels should we conduct the clone analysis? In this paper, we choose the representations from 3 levels, from bottom to top, namely the training code, the deep neural network structure, and the input-output semantics. They can basically represent the behaviors of deep learning models at static, structural, and dynamic levels. However, it still leaves 2 issues to address: how to calculate the structure difference in a more accurate way in alternative ways without knowledge distillation, how to calculate the input-output semantics analysis when the proper training data is unavailable. So, as for the research opportunities regarding clones in deep learning models, we can take the traditional software clone as an example. The traditional software clones have many applications such as code recommendation, refactoring, code smell analysis, and fault localization. However, whether we can do the similar tasks within deep learning models with the clone detected. For example, could we detect the adversarial attack with clone analysis instead of the ineffective transfer attack? How to use the similarity to interpret the deep learning models? Can we reuse the clones in the models to improve the maintainability? So in conclusion, the text clone analysis is not effective when the source code are written by different developers, which makes these levels of clone analysis not very useful in practical, because we cannot assume that all the deep learning models are written by the same group of developers. And for the models with the same structure, which difference is useful? And in the end, the input-output based technicals can represent the similarity, but are very dependent on the inputs. And besides that, several research directions are pointed out. So that's all, and thanks for your patience.